For more than 40 years, the twin crawler transporters at NASA's Kennedy Space Center have slowly traveled the gravel track between the massive Vehicle Assembly Building and the two launch pads at Launch Complex 39. These mammoth beasts that first carried all the Apollo Saturn V rockets have since borne every space shuttle on the last earthbound leg of their journeys to space. The technology used to build these huge, reliable crawlers capable of such Herculean tasks was deeply rooted in a region where giant machines excavated and extracted veins of coal. Engineers with the Marion Power Shovel Company of Marion, Ohio, adapted the technology in the early 1960s, and their know-how has stood the test of time.
You know, one of the decisions that they had to make back then for Apollo was how to get the vehicle out to the pad, and they looked at rail and they looked at the barge, and both of those had issues, and then they finally settled on the crawler. And those guys that designed and built this thing really did a great job. It's a testament to the design and how they put it together that, you know, 50 years later, this thing is still, you know, hauling 12 million pounds around.
When they built the crawler, they overbuilt it, and that's a great thing because it's able to last all these years. You know, I think it's a great machine. I think it could last for another 50 years if it needed to. It's capable, of course, moving the shuttle, all of its parts, and the mobile launch platform. And we're talking about a 12 million pounds. The vehicle itself being 6 million, you have about 18 million pounds rolling down the road.
And as might be imagined, it takes incredible power to move that mass.
All right, this is one of two 2,750 horsepower, 16-cylinder Alco diesel engines. On the other end of these are two 1,000 kilowatt DC generators. So this engine and one just like it on the other end of the crawler is what makes us move. These engines have about 4,000 hours on them or so. So for a 45-year-old, really a 50-year-old engine, they're like brand new. Of course, we've maintained these engines, you know, over the years very well. So these engines will go for another 50 years.
So, with all that weight in motion, what's it like to drive a crawler?
Steering wheel's about the size of a go-kart racer, but it's all electronic. It's all, you know, it's fly-by-wire, so to speak. It's kind of funny. You go up there and that little steering wheel's there, but that steering wheel turns some big cylinders. You know, it moves some big trucks. So it is impressive.
One of the things about driving the crawler is you have to plan ahead, because obviously it doesn't turn on a dime. So you have to really be on your game, and you have to be thinking ahead about where you want to be 1, 2, 3 minutes ahead of time.
The critical nature of the long rollout to the launch pad is not lost on those who operate this huge piece of machinery.
It's very important that all of our systems function properly, safely, from the time we leave the safety of the vehicle assembly building until we get out to the launch pad. So during that 6 hours or so where we're out on the crawler way, it's pretty much just us, you know, my team and the crawler, getting the vehicle out to the pad, and it's a critical time.
With the end of the space shuttle program in sight, soon there will be no more shuttle stacks to ferry to the launch pad. But to those who work on them, the trusty crawlers seem fully capable of moving future launch vehicles if called upon.
Seeing the shuttle program come to an end will be a sad day for us. The crawler actually, you know, has gone through Apollo and shuttle, so it's been around for quite a long time, you know, 40 years. And we'd like to see it maybe carry on to another program if they give us the capability. I mean, the crawler's ready. The crawler's ready to go. It can take on, you know, whatever you throw at it.